Today we shall derive an expression for law of conservation of energy, mechanical energy for freely falling body. According to the statement, according to the law of conservation of energy, energy can neither be created nor be destroyed, but can be transferred from one form to another form. That means potential energy can be converted into mechanical kinetic energy, and kinetic energy can be converted into potential energy, but total mechanical energy remains constant, or the total energy of a freely falling body remains constant at all positions of its free fall. So, consider a body of mass m raised to a height h, or consider a body of mass m at rest at a height h from the ground. Then its velocity at position A is 0 because the body is at rest at a height h, therefore phi equal to 0 and height equal to h. Hence, the total mechanical energy of this body at A is TE equal to PE plus KE, because we know that total mechanical energy is equal to sum of potential energy and kinetic energy. And we have derived potential energy as mgh and kinetic energy as half mv square. So, at A, the position from the ground is h. It is at a height h. Mass m, acceleration due to gravity g, and h, it is the height from the ground. Hence, P equal to mgh plus kinetic energy. Kinetic energy is given by half mv square, but phi at A is equal to 0. Hence, kinetic energy is equal to 0. Therefore, total mechanical energy is equal to mgh. It is at position A. When the body is released due to acceleration due to gravity, the body moves towards the ground. At some instant, the body covers a linear distance of x. It moves from A to B and it covers a distance x. Now the body is at a height h minus x. Total height is h minus x. Therefore, height of the body at B is h minus x. Therefore, at B, phi square equal to, it can be obtained as phi square equal to u square plus 2gx, where x is the distance travelled and u is initial velocity is 0, hence phi square equal to 2gx. The standard equation is phi square equal to u square plus 2as. For freely falling body, a equal to plus g and distance travelled s equal to x. Hence phi square equal to 2gx. And total energy of the body at B is equal to potential energy plus kinetic energy. Potential energy is mg into h, but here h equal to h minus x. H minus x plus half m phi square. but v square equal to 2gx. Here 2 get cancelled, remaining mgx. And simplifying this, mg into h, mgh minus mg into x, mgx plus mgx. Here 2 get cancelled. And minus mgx plus mgx get cancelled, remaining total energy equal to mgh. Consider this as equation 2. Now, as the body reaches the ground, near to the ground, just near to the ground, here h equal to 0. As body reaches the position C, h equal to 0 and v square equal to final velocity of the body before reaching the ground. When it is near to the ground is obtained by using v square equal to u square plus 2as. Here u equal to 0 and a equal to plus g for freely falling body, and total distance travelled s equal to h. Therefore, v square equal to 2gh. And height of the body from the ground at C is equal to 0. And at C, total energy equal to potential energy plus kinetic energy. Since h equal to 0, potential energy is equal to 0, mgh equal to 0, plus kinetic energy is half mv square, that is half m into v square, but v square equal to 2gh. Here 2 get cancelled, remaining 0 plus mgh, that is equal to mgh. Consider this as equation 3. From equations 1, 2 and 3, it is clear that total energy remains constant and that is equal to mgh. Hence, the law of conservation of energy for a freely falling body. And the law of conservation of energy states that energy can neither be created nor be destroyed, but can be transferred from one form to another form. As body moves downward, height decreases. At height decreases, its potential energy decreases, but kinetic energy increases. But the sum of its potential energy and kinetic energy remains the constant. Clear? And it is very important for 5 marks in theory examination. State and explain the law of conservation of mechanical energy or energy for freely falling body. Thank you.